Hello everyone, my name is Linda Gaston. I am your instructor for CS200 Computer Sciences Role in Industry. During this short video, we will review the solution to the Week 2 Painting a Wall lab in your book. So let's get started. Looking at the requirements for the Painting a Wall lab, we see that there are 4 parts to the lab. The first part is to prompt the user to input the wall's height and width. That would look like this. We'll enter the wall height in feet. We'll ask the user to enter the wall width in feet, and we'll calculate the area. It will simply be the height times the width. The second part of the exercise requires us to calculate the amount of paint in gallons that's needed to paint the wall. So in this exercise, you are to assume that the gallon of paint covers 350 square feet, and we're going to store that value in a variable, and you'll see this in a minute. But in short, here we've asked the user to enter the wall height, the wall width, we've calculated the wall area of 180 square feet, and we're simply going to divide the 180 square feet by the 350 square feet that we get out of the gallon of paint. So that gives us a little more than half a gallon of paint that's going to be needed to paint the wall, and you can see that here. The third thing we need to do is calculate and output the number of 1-gallon cans needed to paint the wall. So that means we're going to have to take this fractional component, since we can't buy a fractional gallon of a can, and calculate it to the nearest number of gallons. So in short, we're going to round it up to 1 gallon. So we'll actually end up with 1 can of paint that's needed, even though we're only going to use about half of it. So this is the output that we're going to have here. In the fourth step, we're going to prompt the user for the color that they want to paint the walls. We've already calculated the number of cans that we need, but we want to understand the cost per can. So we're going to ask the user to enter the color they want to paint the walls, and we're going to calculate the total cost of paint depending on the color that's chosen. Now Zybooks gives you a hint here to use a dictionary to associate the paint color with its cost, and you're going to see how to do that in a minute. But for now, you need to know that red paint will cost $35 per gallon, blue $25 per gallon, and green $23 per gallon. So now your output will look like this. We are entering the wall height, the wall width, we're calculating and presenting the wall area, we're calculating and presenting the paint needed. We're going to round that up to a whole can, and then we're going to prompt the user to give us the paint color they want. In this case, it will be red. And then we're going to use the $35 that we agreed would be the cost per gallon of per paint, and we'll print it right here. So now let's take a look at some foundational concepts that we're going to need to do this exercise. Okay, the first thing we need to talk about are some of the libraries or functions that are provided for free from Python. One of them is the Python math module. It's part of libraries that are provided when Python loads up in your system. So this math module contains functions that help us to perform mathematical calculations, so we don't have to code those from scratch. So typically, this function, this math function that we're going to talk about that's part of the math module, will accept one or more values as arguments. And arguments are just simply the information that you give to the function to do its work. And we have to use an import math statement in our program so that this math module is available to us. Let's talk a little bit more about the math module. So for example, if we wanted to find an exponent of a particular number, we would enter that number here, and whatever exponent value that we entered, it would return. Similarly, it would return the exponential value. Similarly, for our ceiling function here, this is going to return the smallest integer that is greater than or equal to the value that we give to the function. So what this means is if we put the 0.51 number that we calculated for the number of gallons of paint that we need, it's going to return the smallest integer that's greater than or equal to 0.51. In this case, it will be 1. So this is how we can round up numbers in Python by using this function. It'll round up to the next highest integer in this case. The next thing we're going to need to understand clearly to do the exercise are dictionaries. So, as discussed in your readings for week 2, a dictionary is a container that stores relational data that's related to each other. And this data is a key and a value pair that's stored in the dictionary. We kind of call this mapping the key to a value. This is very similar to the dictionary that you've used in school, where you look up a value by a key. You look up a key, such as a word, and then you get a value, which is the definition. So if we looked up dog in a dictionary, dog would be the key, and the definition that would come after it would be the value, something like a four-legged animal that barks a lot. So if we want to retrieve a specific value that we've used in a Python dictionary, we use the key that's associated with it. So let's talk about how we would create a dictionary first, and then we'll talk about retrieving the value. So to create a dictionary in Python, which is simply a group of related values, we would have a structure like this. This is just generic. We would have dictionary equals some collection of keys and values. Okay, this is the structure. So this is just a generic structure that we have here. A dictionary would be some collection of keys and values. And to retrieve a value from a dictionary, as I said, we just simply use its key. So we use the dictionary name and its key value. So let's talk about this in relation to our Painting the Wall lab. So in our Painting the Wall lab, we're going to be provided with a dictionary called Paint Colors. Here's how we set up the dictionary and give it values. We simply type Paint Colors, which is the name of the dictionary, equals, and here's how we set up the dictionary. We put it inside of curly brackets. So this is the start of the dictionary. This will tell your Python interpreter that you're creating a dictionary. And then we put these key value pairs. So the key, notice it's within quotations here with a colon, and then the value and a comma, and then all of the others. So now we've set up a dictionary with 3 values and 3 keys. Red as the key, a value of 35, blue as another key with the value of 25, and green with the value of 23. You'll notice these are the prices for the different colors of paint that we just discussed. To retrieve a value in this particular case, and for your lab, we would enter an expression such as our paint cost would equal paint colors, the name of our dictionary, and the key, wall color. Okay. So if we wanted to find out the cost of red paint, we would say paint colors red. Finally, we're going to put some display output on our form, we're going to print some final information for this exercise, and we're going to use format functions to do it. When we use a format function, we use the numeric value that we're going to format and a format specifier. So you'll see when we go through the solution, we're going to use this percentage character. It's going to be the special character that we use to format the expression. It will be the formatting specifier or the conversion specifier. So for the fourth part, we are to calculate, the fourth part of the lab, we are to calculate and output the total cost of paint, of a paint can needed depending on the color. So notice we're using formatting here. Wall color will equal the value that we get from our user, and we're going to put this /n to say that we're going to scoot down a line. That makes us advance one line when we print. And we're going to print the cost of purchasing paint. We're going to use this formatting expression and this formatting expression. What this simply says is this value will, whatever is here will be printed as a string, and whatever is here will be printed as an integer. So notice we have this string value and then the word paint and then a $sign and then this integer value. These two formatting expressions line up with this one and this one. So wall color will be as a string, paint cost will be as an integer value. So let's get started creating our lab. Notice we have the import math function. This gives us access to the ceiling function that we're going to need to round up the number of cans of paint that we're going to calculate that will be needed. We're also given, see the comment here, the dictionary for our paint colors dictionary, and notice the three name key value pairs that we have here. For the first fix me, we want to prompt the user to input the wall's width. And we're going to calculate and output the wall's area. So we're going to ask them to actually ask them to input that wall's width in the following manner. Wall width equals float sub input To save time on the video, I typed ahead. So here, if we want to calculate the output wall area, we're going to prompt the user for the wall height and width. Notice we're using the input instruction, which prompts the user to enter a value, and the prompt is included here. We have a formatting string to advance to a formatting expression to advance to the new line. So this takes what the user has entered in this prompt, converts it to a float. Remember, what the user enters from a prompt comes in originally in a string value. We need to use this for math, so we're going to convert it to a float. So we take this prompt, the value that comes from it, and we convert it to a float and we put it in here. Similarly, we take this prompt, the input that the user provides is converted to a float and put in here. Next, we want to calculate and output the wall area. Again, to save time, I typed ahead. So the wall area is going to be equal to the wall height that we got here from the user's input and the wall width that we got from the user's input. We simply multiply the two of those together, and that gives us the wall area as we discussed. Here we print back to our user the wall area that we calculated simply by printing the string wall area, then the wall area variable that we calculated in square feet. So it would be wall area equals 150 square feet, or whatever the answer is based on the user input. To save time on the video, I typed ahead for Fix Me number 2. This is where we calculate and output the amount of paint in gallons needed to paint the wall. And that is simply the gallons needed that we calculated. The gallons needed that we will calculate will equal the wall area that we calculated divided by 350, which is the amount of paint that we get from 1 gallon of paint. In Fix Me 3, we use the math ceiling function that we discussed earlier to calculate and output the number of 1 gallon cans needed to paint the wall. So we take the gallons needed that we calculated, remember that's going to be in a fractional component, and we use that as an argument into this math.ceiling function. So we put the math here. This math denotation here indicates the math library or module that I imported into my program, and I'm using the ceiling function from that module. The gallons needed is the argument that's passed to this function. So it's going to round it up to the nearest integer as we discussed and put that value in cans needed. Finally, in Fix Me For, we're going to calculate and output the total cost of the paint depending on the color. So we're going to ask our user via this input prompt to choose a color to paint the wall. We're going to advance down one line, and we're going to take, using the key value that we get from our user, we're going to use this key value with our dictionary. Remember, the Paint Colors Dictionary is where we've specified all of our cost for the different paint colors. So we're going to use the value that was inputted by the user as the key to the dictionary. That's going to give us the cost of whatever color they enter. We take that cost and multiply it times the cans needed, and we simply print it here in the same manner that we've discussed. This concludes the explanation of Lab 3.11, Painting a Wall in SciBooks. If you have any questions about this exercise or would like to schedule an individual virtual office session, please contact me as soon as you can at l.gaston@snhu.edu. This concludes the video. Thank you.